Hello future professionals, welcome to day 27 of our top 100 coding question analysis. Today we are challenged with the question to print a Fibonacci series of length n using recursion. Let's look at the steps we will adopt to solve and understand the solution. The steps involved in this video to solve this problem would be: first, we will understand what is recursion, that is, get to know the definition of recursion. Next, how is it done? It will be covered in the second step where we study the code. Next, we will take a glance of the output and perform debugging. Next, we will try to understand the recursion concept completely using hands-on experience. Let's now look at the definition of recursion. Recursion is a concept which simply means that a function calls itself repeatedly until it satisfies the base condition. Let me repeat, recursion is a concept which simply means that a function calls itself repeatedly until it satisfies the base condition. Right? Let's move on to the second step where we study the code, that is, effectively know how recursion is performed. We shall study the code. First, we start the code by defining a function, that is getUserInput function. Here, we get the length of the series from the user and store the value in the length variable. Next, we return the length variable. Next, we define a function Fibo and pass the argument as n. Here, within this function, we check whether the passed value, that is n, is less than or equal to 1. If it is less than or equal to 1, then we return n. Else, we here perform the recursion concept. Next, we call the getUserInput function and store the return value in the length variable, that is L variable. Now we check whether L is less than or equal to 0. If it is less than or equal to 0, then we print enter a valid length. Else, we use a for loop to print the individual digits until we reach the length of the series. Now let's look at the output of the program. The program is asking me the length of the series. Let me enter 5. I get the series as 0, 1, 1, 2, 3. Right? Now that we have looked at the output, let's debug the program. Let me point the debugger pointer here where we start the program. Let me start debugging. So we enter here. Let's move on to the next step, that is, it is asking me to enter the length of the series. Let me enter 5. Right? Next, what happens in threads and variable? We have initialized. Let me bring this down. Right? Here, as we have called the getUserInput function, the control has passed here. We have given the input as 5 and length is assigned to 5, as you can see. Next, we return the length variable. Right? What happens next is that we come here where L is assigned the value of 5. Next, we check if L is less than or equal to 0. It is greater than 0, so we move to the else part. Here, we execute the for loop. Right? Now, I is assigned the value 0. Right? Next, we move inside the for loop and we execute the print statement. Within the print statement, we call the function Fibo. Right? Now, the control will pass to the Fibo function, as you can see. Next, it checks whether the passed value is less than or equal to 1. Since n is 0, it is less than 1. So, we return n itself, that is 0. Here, in the console, we would have printed 0, as you can see. Next, the step would be, we again execute the for loop where now the value of I is incremented. You can see I's value is incremented to 1. Next, we execute the print statement where we call the Fibo series function. Here, it enters the Fibo function and checks if the passed value is less than or equal to 1. As 1 is equal to 1, we return n, that is nothing but 1 itself. Now we see that 1 is printed. Next, we execute the for loop. Once again, I is incremented to the value of 2. Right? Next, we execute the print function within which we call the Fibo function. Next, the control is passed to the Fibo function. We check whether n is less than or equal to 1. As n is equal to 2, we pass the control to the else part, that is the block within the else. So now that we have entered in the else part where recursion happens, here let's check what happens. Here, as we have passed n equal to 2, we call the function by passing the argument as n minus 1, that is 2 minus 1, 1. Now n is getting the value 1. It checks whether n is less than or equal to 1. As 1 is equal to 1, we return 1 as the answer. So this is how recursion is performed. Right? Now we get the output as 1, which is the third element. Now let's skip all the steps and look at the entire output, that is 0, 1, 2, 3. Now that we have got the glance of the output and we have also debugged the program, let's understand the recursion in depth. To understand recursion in detail, I have defined the Fibo function here, and we shall output the numbers individually until we reach the length of the series. But before we do all of these things, we shall know what is a Fibonacci series. Fibonacci series is 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. How do I get these numbers? The first two numbers are fixed, that is 0 and 1 are fixed. From the third element onwards, we get the number by adding the immediately previous two numbers, that is, we obtain the third element by adding the first element and the second element. First element and the second element. First element is 0, second element is 1, so we get the output as 1, which is the third element, right? Now for the fourth element, we add the second element and the third element, which is second element is 1, third element is also 1. When we add, we get 2, right? 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, and so on it goes, right? Let me erase this once. Now we have got the idea that the first two numbers, that is 0 and 1, are fixed and the others are derived, right? So with this understanding, let's take a list to understand the problem better, right? Zero, 1, 2, 3, 4, and 5, right? But the first element stays in 0th index, second element stays in first index, third element second index, fourth element third index, fifth element fourth index, sixth element fifth index, right? So we will not use list in our program, but to get the understanding, to get the clarity, we will relate the series to a list, which is obviously correct because list is also a series of numbers stored in consecutive memory locations, right? So there is nothing wrong in we assuming the series to be in a list, right? So as we know, the first element is 0 and the second element is 1. This is fixed, right? But as we do not use the list, we must get the output as 0 and 1 here. So do you notice a pattern here? The first element and the second element has a pattern with their indexes. Yes, the first element is same as the index number and the second element is same as the index number, that is nothing but 0 and 1. So when we pass the value of 0 or 1, we must get the same value as 0 or 1. So how do we do this? We insert a condition where if n, which is passed value, is less than or equal to 1, that is 0 or 1, we pass the same output, right? That is 0 or 1, right? Next, from the third element onwards, here The third element is nothing but, let me call this list as Fibonacci series. Fibonacci series of 2, that is at the index 2 we have the third element, right? If I want to find the third element, I will have to add the element present in the first index plus the element present in the 0th index, that is immediately previous two elements, that is 0 and 1. So what is there in Fibonacci series 1? We have 1. What is there in Fibonacci series of index 0? We have 0. What is the sum? 1. So where should I input it? Here, right? But how does this happen in recursion? Here, when we want to get the first element, we pass 0. When we wanted second element, we passed 1. When we want the third element, we have to pass the value as 2, right? So let me erase this. Now let us look at how recursion works. We have passed 2. Okay, now here n is equal to 2. Now we check whether 2 is less than or equal to 1. No. So the else condition, the else part is executed. Here we return Fibonacci of n minus 1. What is n? 2. N minus 1 is 1. Next, plus Fibo of, what do we have? N minus 2. N is 2, minus 2 is 0. Right? This is what we call as recursion. We call the function by itself. The function calls itself repeatedly until a base condition is satisfied. This is our base condition, right? So let's work it out here. Let me call this a workout area. Let me call this workout area, right? Here, what is the challenge we have faced? The function is calling itself in such a way, right? Now we will execute this part of the function. When Fibo of 1 is called, what happens is that n is assigned to the value 1. Next we check whether 1 is less than or equal to 1. Yes, so we return the same value 1. Now this value is passed here, 1. Next we have plus. Next we call Fibo of 0. What happens? N is assigned the value of 0. We check whether 0 is less than or equal to 1. So we return 0 itself because we return the same value which has been passed. So this is passed to this function. So we return here and the statement goes 1 plus 0 is 1. So this Fibo of 1 plus Fibo of 0 equal to 1. Where is this called? It is here. So this is equal to 1. So what do we do next? We return 1. It comes here, right? When we get to know how 4th, 5th and 6th element are obtained, we'll get more clarity onto how this recursion function happens, right? So don't worry if you didn't get it in the first instance. We will try it for the next 3 elements, so you will get a complete understanding of how this works, right? Now what do I want? I want the 4th element. I will pass the value 3. So now n is equal to 3. Now let me check whether 3 is less than or equal to 1. No. So I will execute the else part. In the else part is where recursion happens. I call the Fibonacci series of n minus 1. What is n? 3. So I call Fibo of 2 plus Fibo of n minus 2. What is n? 3. N minus 2 is 1. So we'll decode it here. That is Fibo of 2 plus Fibo of 1, right? Now as we have called the function here, let's decode this first. Now Fibo of 2 does nothing but it is calling the Fibo function once again. What happens inside the Fibo function? First we check whether n is less than or equal to 1, right? But what is n? As we have passed 2, n gets the value 2, right? Now is 2 less than or equal to 1? No. So we execute the else part. What happens in the else part? We again perform recursion, that is fibo of what is n? 2. N minus 1 is 1. Next fibo of n minus 2, that is 0. Right? Now we again call the function fibo. Now what happens? We assign the value of 1 to n and check whether 1 is less than or equal to 1. So as 1 is equal to 1, we return the value 1. Where is it written? It is written where it has been called, right? Now the value is 1. Next we have the plus operation. Next we call the Fibonacci series, the Fibonacci function with parameter with the argument 0, right? Now n is assigned 0 and we check 0 is less than or equal to 1. Yes, so we return the same value that is passed. Now we get the value 0. Now this is equal to 1. Who called these two functions? That was this function. So pass 1 to this function. The value of this function is 1. Next, as we have called the Fibo function with the argument as 1, we assign n to 1 and check whether n is less than or equal to 1. As this is equal to 1, we return 1 as the output. This function call gets the value as 1. In between we have plus operator, so when we add we get 2, right? Where is Fibo 2 plus Fibo 1 called? Here. So Fibo 2 plus Fibo 1 is equal to 2. What do we do next? We return 2. We get the output as 2. As we enter here, we also get the output here. First we got 0, next we print 1, next we print 1. Now that we have printed 2. Next we want the fifth element, so we will pass 4 as the argument. Let me clear all this. Right, now we call the function by passing the argument as 4. Now n gets the value 4 and we check whether 4 is less than or equal to 1. No, so we execute the else part. Here recursion happens where we call the Fibo function of n minus 1, that is 3, plus Fibo of n minus 2, that is 2. Now we shall decode it here. Fibo of 3 plus Fibo of 2, right? Let me separate this so that we understand it clearly. When Fibo 3 is called, we assign the value of n to 3 and check whether 3 is less than or equal to 1. No, so we execute the else part, which is Fibo of n minus 1, that is 2, plus Fibo of n minus 2, that is 1. Now what happens? Now n is assigned the value of 2, right? Then we check whether n is less than or equal to 1. No, so we execute the else part, that is Fibo of n minus 1, that is 1, plus Fibo of n minus 2, that is 0. Now what does n minus 1 do? Assign n to 1 and we check whether 1 is less than or equal to 1. It is equal to 1, so we return the value 1. It is returned to this function call. Next we have plus, then we call the Fibo by passing the argument as 0. Now n is assigned the value of 0, then we check whether 0 is less than or equal to 1. As it is less than 1, we pass the same value that has been passed. Okay, now we get the value of the function call to be 0. The resultant is 1. Now who called these two functions? It was this function. So this function call's value is 1. Next we have the plus operator. Next we call function Fibo function by passing the argument as 1. Here n is assigned the value of 1 and 1 is checked whether is less than or equal to 1. As it is equal to 1, we pass the value 1 itself. So we get the value here 1 and this is equal to 2. Now who called these two functions? It was this function. So we pass the value 2 to this function call. Next we add and call the Fibo function by passing the argument as 2. Now what happens is that we assign n to the value 2 and check whether 2 is less than or equal to 1. No, so we execute the else part where recursion happens. So n minus 1 is 1 plus fibo of n minus 2 is 0. What does fibo 1 do? It assigns n to the value of 1 and check whether n is less than or equal to 1. As it is equal to 1, we return the value 1. Right? This function call gets the value 1. Next we call the fibo function by passing the argument as 0. So n is assigned the value of 0 and we check whether 0 is less than or equal to 1. Since it is less than 1, we pass the value 0. Right? What is the resultant? We get 1. Now who call these two functions? This function call. So let us pass 1 to this function call. Right? Now what is fibo 3 plus fibo 2? It is 3. As you see, 2 plus 1 is 3. Now what do? We equate this to 3 and what do we do next? We return 3. That is, the fifth element is 3 and we output 3 as the answer. Right? And now we have to find the next element. I assign this as an homework to you. If you were able to decode it in the similar way, I can definitely tell you that you have understood the recurrence concept very well. Else, don't worry, rewatch this video to get full understanding of how recursion happens, right? Now that we have understood the steps we use to solve this problem, I hope you would have got the best out of this video. I recommend you to subscribe our channel to get more such interesting videos, and I also recommend you to like and share the videos if you find it supportive and interesting.